Good morning, everybody. Today I want to talk to you about airflow. If I asked you guys to think about air and what it is, I speculate that I would get answers as to, oh, air is what we breathe. If I asked you what air was, you might say that air is a gas. And it is made up of many different types of gases. But I would challenge you guys and say, did you know that air is a fluid as well? And you might say, oh, but a fluid is a liquid. Well, technically that is true. But a fluid is any substance that flows and has an indeterminate shape. That means it's not defined as to what the shape of it is. We actually talk about airflow. We talk about it moving two different ways. When air flows horizontally, we give it a special name. That's called wind. So this is airflow across the surface of the planet. We call it wind. When air flows vertically, this is upwards. It has a special name. We call it lift. When air flows vertically downward, that's called a downdraft, and we're going to be talking about that later when we're talking about weather. Today, I want to talk specifically about lift. How does lift work? What causes the air to move upward instead of horizontally? There are two mechanisms. The first one is called orographic. Orographic lifting occurs when air is lifted over a physical obstacle. What does that look like? Here's my mountain. And out here is the ocean. The air out over the ocean has been warmed up by the sun. And it is moving horizontally over the surface. And when it moves horizontally over the surface, we call that wind. As that air is moving over the water and it is being warm, it's causing some of that water to evaporate, and that warm air is filling up with water molecules. As that warm air is traveling along, it comes to the side of the mountain, and some of it goes around the mountain, but a good portion of it is forced upwards. This is called the windward side of the mountain. That warm, moist air is forced upward. We talked about as you go up in elevation, your temperature decreases. As warm, moist air is forced upward, it cools, and all of that water comes out of the air in the form of rain. And it dumps all of its water on the windward side of the mountain. On the other side of the mountain, this is called the leeward side. That air comes down the other side of the mountain, and it is now cool and dry. I want you guys to think about, when you're picturing this in your mind's eye, I want you guys to think about the western part of the United States. This is not to scale. We have Washington is on the top, Oregon, and California. Here in Washington and Oregon are the Cascade Mountains. And in California, we have the Sierra Nevada, and that warm air has just come to our west coast all the way across the very wide and unencumbered Pacific Ocean. And it hits those mountain ranges and is forced upward. And immediately begins to cool. In our Pacific Northwest, this creates a rainforest. And here, where it hits the Sierra Nevada, it has produced some spectacular growing conditions. On the leeward side of the mountains, where it is drier, we have our deserts of our southwest. And up here in the northern part of the Pacific Northwest, on the leeward side, there are drier growing conditions. So there is an example of how a geographic physical obstacle affects airflow and local weather. The second kind of lifting that occurs is called frontal lifting. Frontal lifting is when one air mass is lifted over another air mass. What is an air mass? It's just like it sounds like. An air mass is a large body of air. That moves across the land. I guess, or ocean. And it brings the weather with it. Now, what type of air mass is in place kind of depends on where the air mass originated. A cold front are air masses of dense, dry air with cold temperatures. And a warm front has humid and wet air with warm temperatures. Now, when you hear a meteorologist talking about a cold front or a warm front, these warm and cold temperatures are relative to the time of year. So if it's been 90 degrees all week and a cold front is moving in, that cold air is just cooler than the current temperatures. So the cold front could be 70 degrees. If it's the winter time and a cold front is moving in, well, if it's been 32 degrees and colder air is coming in, now the cold front might be minus 10 degrees. So the same is true if it's the winter time and a warm front is coming through. If it's been 32 degrees, that warm front might be 40 degrees. So please understand that the cold and warm temperatures of the front are relative to the local temperatures and where that air mass originated. So what happens when two fronts meet? So when we have a warm front, meeting a cold front, that cold front is going to force the less dense warm air to rise very quickly. Here's our cold front. Our warm front is moving up from the south because the air is much warmer down there, and it bumps right into that cold front. And it forces that hot air to rise very quickly. So when the warm front meets that cold front, the warm air is forced upward. And thunderstorms occur. Particularly in the summertime. So this is how we get our thunderstorms. The warm air right on the boundary causes a bunch of water to come out of the air at the cold front and makes a line of thunderstorms. What happens when a cold front meets a warm front? So when a cold front comes along, and meets a warm front, mixing occurs, but it is not quite as dramatic. Our warm front is less dense air. And it has been sitting here for a couple of days. It's been warm and sunny. And a more dense cold front moves in. And it displaces that warm air slowly. And because it is displacing that warm air slowly, the warm and cold air mix. And what we have, instead of a big thunderstorm, is a lot of rain over a widespread area. So when the cold front meets the warm front, we get mixing. The air is lifted slowly. Mixing of the mixing of the air masses occurs. And we get rain over a wide area. I'm going to post again for you guys the little video that I made a few weeks ago about the warm air and the cold air mixing, rather than run the risk of actually doing that experiment again and having it fail for me. Tomorrow I'm going to be talking about wind specifically and how it moves, high pressure and low pressure. And then we will be talking a little bit more about weather and what is happening.